In 1977, humanity launched Voyager 1. It is currently the fastest object we have ever built, tearing through the void at 38,000 miles per hour. That sounds fast. But if Voyager were headed for our absolute nearest neighbor, Proxima Centauri, it wouldn't get there in our lifetime, or our children's lifetimes. It would take over 73,000 years. The universe is simply too big and our rockets are too slow. But science fiction offered a solution: the warp drive. The ability to engage an engine, blur the stars, and cross the galaxy in days. For decades, physicists dismissed this as pure fantasy. Einstein's special relativity is strict. Nothing with mass can travel faster than the speed of light. To do so would require infinite energy. But perhaps we have been looking at the problem the wrong way. What if we don't move the ship through space? What if we move space around the ship? In 1994, a theoretical physicist named Miguel Alcubierre found a loophole in Einstein's equations. He realized that while objects cannot move faster than light, space itself can expand or contract at any speed it wants. It happened right after the Big Bang, and it's happening right now at the edge of the universe. Alcubierre proposed a device that creates a bubble of flat, normal space around a starship. The mechanism is elegant. The drive compresses the fabric of space in front of the ship, pulling the destination closer. Simultaneously, it expands the space behind the ship, pushing it away. Think of it like a surfer on a wave. The surfer isn't paddling, they are standing still on their board. It is the wave of water underneath them that is moving them forward. In this scenario, the ship is the surfer and space-time is the water. Inside the bubble, the ship feels no acceleration. A crew could cross the galaxy in a week without even spilling their coffee. Mathematically, it works. It doesn't break general relativity, but physically the concept faces immense challenges. Gravity is attractive. Mass, like the Earth or the Sun, bends space-time inwards. But to make a warp drive work, we need to do the opposite behind the ship. We need to expand space. To do that, we need something that exerts anti-gravity. We need negative energy. This brings us into the strange domain of quantum physics. In classical physics, energy is always positive, but in quantum field theory, there are hints that negative energy is possible. We see this in the Casimir effect. If you take two metal plates and place them nanometers apart in a vacuum, the quantum fluctuations outside the plates are stronger than the ones squeezed between them. This pushes the plates together. The space between them technically has a lower energy density than the zero of the vacuum. It is effectively negative energy. So the fuel for a warp drive isn't antimatter or dilithium crystals. It's a manipulation of the quantum vacuum itself. If we have the math and we have the quantum theory, why aren't we visiting Alpha Centauri yet? There are three massive obstacles standing in the way. First is the cost. When Alcubierre first ran the numbers, creating a warp bubble for a small ship required more negative energy than there is mass in the entire observable universe. Later calculations refined this down to only the mass energy of the planet Jupiter. Converting the entire planet of Jupiter into pure negative energy is currently beyond our comprehension. Second is the death ray problem. As a warp bubble travels, it would sweep up high-energy particles from space, trapping them in the shell of the bubble. When the ship arrives at its destination and turns off the drive, all those captured particles would be released in a single focused blast of gamma radiation. A ship wouldn't arrive as an explorer, it would arrive as a weapon, incinerating the very world it came to visit. And third is causality. If you move faster than light according to relativity, you are technically moving backwards in time for certain observers. A warp drive isn't just a spaceship, it's a time machine. And the universe tends to resist time paradoxes. It sounds like a dead end. But theoretical physics moves fast. Just in the last few years, physicists have published new solutions suggesting that by arranging plasma in specific microscopic structures, we might be able to create a warp bubble using only positive energy. no exotic negative mass required. The trade-off is that these positive energy drives might not be able to break the speed of light. But they could get us close, reaching 50% or 90% of light speed without the crushing G-forces that would normally kill a human crew would still revolutionize space travel. We often look at the sky and wonder if other civilizations are visiting us. But if the laws of physics are as stubborn as they seem, maybe nobody is warping around the galaxy just yet. We are still a Type 0 civilization. We are still learning how to crawl. The warp drive remains on the chalkboard for now. But the fact that the math allows it, that the universe has left the door slightly ajar, means that one day humanity might just figure out how to walk through it. It began with a shadow. Not a shadow cast by light, but a shadow cast upon film. In 1945, the world changed forever, but most of humanity didn't know it yet. The United States government had detonated the first atomic bomb, the Trinity test, in the deserts of New Mexico. It was a top-secret project, hidden behind layers of classification and silence. But thousands of miles away in Rochester, New York, a private company figured it out. Kodak, the photography giant, suddenly had a crisis. Their sensitive X-ray film was being ruined. It was fogging up inside the packaging, rendering it useless. Their physicist, Julian Webb, investigated the cause and traced it back to the cardboard packaging. The straw used to make that cardboard had been grown in the Midwest, washed by river water. Webb realized that the river water had been contaminated by a new, mysterious type of radioactive dust falling from the sky. Kodak had accidentally discovered nuclear fallout before the public even knew what an atomic bomb was. It was the first warning that when we unleash the power of the atom, it doesn't stay where we put it. It enters the water, it enters the soil, and eventually it enters us. That discovery marked the dawn of the atomic age, a terrified era defined by the Cold War arms race. For decades, global superpowers detonated thousands of nuclear devices, some underground, some in the atmosphere. They released isotopes like strontium-90 and cesium-137, distinctive fingerprints of humanity's ability to destroy itself. We told ourselves we could control this fire, but history is a graveyard of that arrogance. In 1986, the name Chernobyl became synonymous with invisible death. A reactor design flaw compounded by human error blew the lid off the core. It spewed a plume of radioactive debris that circled the globe. It wasn't just an explosion, it was a poisoning. The land around Pripyat remains a ghost world today, a place where the trees turned red and the soil itself became an enemy. Then in 2011, nature humbled our technology in Japan. The Tohoku earthquake and tsunami slammed into the Fukushima Daiichi nuclear power plant. Meltdowns ensued, but unlike Chernobyl, the primary fear here wasn't just the air, it was the water. Millions of gallons of radioactive water leaking into the Pacific Ocean, raising terrifying questions about the marine life we rely on for food. This brings the horror home. We tend to think of radiation as something that happens over there, in exclusion zones or test sites. But the terrifying reality of the nuclear age is that the fallout doesn't vanish, it migrates. Radionuclides settle on grass, cows eat the grass. The radiation concentrates in their milk. It falls on the oceans and bioaccumulates in the fish. In the modern world, agencies like the FDA maintain a constant silent vigil over our food supply. They issue alerts and advisories monitoring imported foods from areas known to have lax regulations or recent contamination events. We have seen advisories regarding seafood, like frozen shrimp from specific international firms, pulled from distribution lines. While many recalls are for pathogens like Salmonella, the infrastructure to test for radiation is more critical than ever. The concern is that man-made isotopes, the refuse of our nuclear history, can end up on your dinner plate. The idea that an imported bag of shrimp or a crate of produce could carry the silent signature of a nuclear accident is a uniquely modern anxiety. However, if you were to take a Geiger counter to your kitchen right now, it would click. And it wouldn't be because of a bomb testing site in Nevada or a meltdown in Japan. There is a widespread misconception that radioactivity itself is unnatural, that it is purely a creation of mad scientists and weapons programs. We have learned to fear the word radiation. But according to the EPA, radioactivity is as natural as the air we breathe. In fact, if you want to find a source of radiation, you don't need to look at a nuclear reactor. You just need to look at a banana. This is where the science gets fascinating. Bananas are rich in potassium, and a tiny fraction of all potassium in the universe is the isotope potassium-40. It is naturally radioactive. Every time you eat a banana, you are ingesting a small amount of radiation. It's not just fruit. Brazil nuts are famous for containing high levels of radium-226 and radium-228, drawn up by the tree's massive root systems from the soil. Lima beans, carrots, potatoes, and red meat, they all carry a faint radioactive signature. Does this mean your pantry is a nuclear waste dump? No. The truth is, you are radioactive. Your body contains potassium, carbon, and other elements that have radioactive isotopes. As you sit here listening to this, your own body is undergoing roughly 4,000 radioactive disintegrations every single second. You are emitting radiation into the room around you. The EPA and food safety scientists distinguish clearly between natural background radiation and contamination. The human body has evolved over millions of years to handle potassium-40. We have a homeostatic mechanism that regulates the amount of potassium in our system. If you eat 100 bananas, your body doesn't hoard the radiation, it processes it. This natural radioactivity is distinct from the heavy man-made isotopes like plutonium or strontium-90 that mimic calcium and lodge themselves in our bones. Those are the killers. Those are the legacy of the arms race. So where does that leave us? We must remain vigilant against the errors of our past, the leaking reactors and the weapons tests that stained our atmosphere. We must support the agencies that scan our imported food for the fingerprints of disaster. But we must also stop fearing the word radiation itself. It is the heat of the sun. It is the soil beneath our feet. It is the potassium in our blood. We are children of a radioactive universe, living in a delicate balance between the energy that sustains life and the energy that can end it.
We have arrived at Gaia BH1, located just 1,560 light-years from Earth. This is the closest black hole to our home. But unlike the monsters in movies, this one is silent. It is a dormant black hole. It is not currently feeding on a star, so there is no glowing disk of fire to warn us. There is only gravity. It is a ghost, a region of space where a sun 10 times the mass of our own simply vanished, leaving behind a scar in the fabric of reality. We cannot enter ourselves. The gravitational tidal forces would tear our biology apart before we even reach the threshold. Instead, we send a probe, a hardened vessel designed to survive the descent, at least for a few moments. As the probe approaches the event horizon, the point of no return, something strange happens. From our perspective on the ship, the probe begins to slow down. The light from its thrusters turns red, then deep infrared, as the immense gravity stretches the light waves themselves. To us, the probe never actually enters. It simply freezes, fading into a dim red ghost, stuck forever on the edge of the abyss. But for the probe, the reality is violent and instantaneous. Inside, the laws of physics as we know them shatter. The probe is subjected to spaghettification, gravity pulling so much harder on its nose than its tail that it is stretched into a long, thin stream of atoms. But what lies at the center? A singularity? An infinitely dense point where time and space end? Or is it a bridge? Some physicists theorize that black holes are not dead ends, but doorways, Einstein-Rosen bridges connecting to white holes in distant galaxies, or, perhaps, the birth canals of entirely new universes. We will never know. The probe is gone. Its data is lost to the darkness forever. We attempt to leave the system, but as we engage our drive, the fabric of space-time itself begins to buckle. Our sensors aren't picking up radiation or matter. They are detecting a chirp, a ripple in the geometry of the universe so powerful it distorts the laser light of our instruments. We have just crossed the wavefront of a cosmic cataclysm. GW250114. Back on Earth, on January 14th, 2025, this wave washed over the planet. It was detected by the LIGO and Virgo observatories as the clearest, loudest gravitational wave signal in history. A signal-to-noise ratio of nearly 80, shattering all previous records. It was the death scream of two black holes, each 30 times the mass of our Sun, colliding at nearly the speed of light. For the first time, this signal allowed us to hear the ring down. Just as a bell hums after being struck, the newly merged black hole vibrated, emitting specific frequencies, or overtones, as it settled into a stable shape. This event confirmed Stephen Hawking's famous area theorem, proving that the surface area of the new black hole was greater than the sum of the two that created it. Entropy only increases. The monster only grows. The wave passes. The ripple continues its journey into the infinite dark, a permanent record of a violent merger that happened over 1 billion years ago. We are left in the stillness once more. But the universe has other ways to destroy worlds. Our sensors have picked up something even stranger, a world that shouldn't exist. We have reached the system of PSR J2322-2650b. This is a Jupiter-type planet, but it is nothing like the gas giant we know. It orbits a pulsar, a rapidly spinning neutron star that rotates hundreds of times per second, blasting out beams of deadly radiation like a cosmic lighthouse. The gravity here is so intense that it is physically tearing the planet apart, stretching it into the shape of a lemon. This world defies explanation. The James Webb Space Telescope observed this atmosphere and found it wasn't made of hydrogen and water, but of pure carbon and helium. It is a world of soot and smoke. But the true wonder lies deep below the crushing clouds. The pressure here is so intense that the carbon core of this planet has likely crystallized. This is not just a gas giant. It is a diamond world, a trillion-carat jewel being slowly vaporized by the dead star it orbits. Pulsars like this one are the most precise clocks in the universe. Their pulses are so regular that we use them as cosmic milestones. In fact, we use them to draw a map. Decades ago, when we launched the Voyager probes, we included this map. It uses the unique frequencies of 14 nearby pulsars to triangulate the exact location of Earth. It was meant to be a greeting, a way for any intelligent species who found it to find their way to us. But as we drift through this dark, predatory universe, past black holes that devour light and dead stars that tear planets apart, we must ask ourselves a terrifying question. Was it a mistake? In a forest this dark, is it wise to shout, "I am here"? If there are other eyes watching the pulsars, other ships navigating the dark, we have just handed them the keys to our front door. And not everyone who knocks comes in peace. From the deepest reaches of cosmic history to our own planetary backyard, 2025 was a year that redefined our place in the universe. We launched new titans into the sky, discovered new worlds, and found tantalizing clues in the great search for life itself. As we close the chapter on a remarkable year, these are the top 10 space moments of 2025. Number 10. A new titan of the spaceways. For years, the world watched and waited. In 2025, a new behemoth of private spaceflight finally took to the skies. Blue Origin's New Glenn rocket, a true heavy-lift vehicle, successfully completed its inaugural launch, deploying a fleet of satellites into orbit. The launch marked the arrival of a major new player in the race to access space, promising to lower costs and open up new possibilities for science, commerce, and exploration. Number 9. The solar system gets a little more crowded. Our map of the solar system was redrawn in 2025, with the discovery of 3 new faint moons orbiting the ice giants, Uranus and Neptune. These tiny worlds, some no more than 8 kilometers across, were found hiding in the noise of old telescope data by powerful new algorithms. The discoveries remind us that even in our own cosmic neighborhood, there are still secrets waiting to be found. Number 8. A new cosmic speed record. Pushing the limits of engineering, NASA's Parker Solar Probe continued its daring mission to touch the Sun. During an incredibly close pass of our star, the probe achieved a staggering new speed record, an unimaginable 192 kilometers per second. That's fast enough to circle the Earth nearly 5 times in a single minute. The probe gave us our closest ever look at the Sun's atmosphere, all while becoming the fastest object ever built by humanity. Number 7. New neighbors in our cosmic backyard. The stars next door became a lot more interesting in 2025. After years of searching, astronomers confirmed the existence of 4 rocky exoplanets orbiting Barnard's star, one of our closest stellar neighbors. Not long after, the James Webb Space Telescope found the most convincing evidence yet for a Saturn-sized gas giant orbiting Alpha Centauri A, the star right next door. While not habitable worlds, these discoveries prove that planets are everywhere, even on our very doorstep. Number 6. The visitor from another star. In July, astronomers spotted something moving fast and on a strange path. They had found 3 I/Atlas, only the 3rd interstellar object ever discovered passing through our solar system. This visitor from the great beyond gave us a priceless opportunity to study a piece of another star system up close. While its chemistry was broadly similar to our own comets, subtle differences in its composition offered clues about its alien origins, a direct message from a distant, unknown star. Number 5. The riddle of dark energy deepens. The universe is expanding at an accelerating rate, driven by a mysterious force called dark energy. In 2025, the Dark Energy Spectroscopic Instrument released the largest 3D map of the cosmos ever created, and it came with a shocking twist. The data suggests that dark energy may be weakening. This profound discovery challenges our standard model of cosmology. If the universe's expansion is indeed slowing down, it could mean the ultimate fate of everything is not a cold, empty future, but a catastrophic big crunch. Number 4. Webb gazes into the cosmic dawn. The James Webb Space Telescope continued to revolutionize our understanding of the early universe with a stunning 1-2 punch of discovery. First, Webb identified the dying flash of the earliest supernova ever seen. It detected the light from a collapsing star that exploded when the universe was just 730 million years old. At the same time, Webb solved the mystery of the little red dots it had been seeing in its deepest images. These aren't just galaxies. They are the birth cries of the first supermassive black holes, confirming how the universe's first giants were born. Number 3. The whispers of alien air. Could we detect life on a planet light years away? In 2025, we got our most tantalizing hint yet. Pointing the Webb telescope at the exoplanet K2-18b, a potential Hycean, or ocean world, astronomers found stronger evidence for the presence of dimethyl sulfide. On Earth, this gas is overwhelmingly produced by life, particularly marine phytoplankton. While not yet definitive proof, finding such a strong biosignature in the atmosphere of a distant, water-rich world is a monumental step in the search for life beyond Earth. Number 2. The asteroid that buzzed the Earth. In late 2024, an asteroid named 2024 YR4 was discovered on a worrying trajectory. For months, astronomers refined its orbit, confirming it would miss our planet, but only just. In November 2025, the asteroid, estimated to be the size of a skyscraper, made an exceptionally close pass of Earth, coming well within the orbit of the Moon. The event was a stunning spectacle for observers and a sobering reminder of the importance of planetary defense, highlighting the very real dangers lurking in the cosmos. Number 1. life's fingerprints on Mars. For centuries, we have looked to Mars and asked, was there ever life? In 2025, we got the most compelling evidence to date that the answer might be yes. NASA's Perseverance rover, studying a rock nicknamed Chayava Falls, analyzed a pattern of distinctive leopard spots. Scientists on Earth announced that after ruling out other possibilities, the leading theory for the formation of these intricate markings is the action of ancient Martian microbes. This discovery is a potential game-changer, moving the search for alien life from a question of if to a question of when we will find the proof. It was, without a doubt, the biggest space moment of 2025. In the vast, silent emptiness of the cosmos, humanity has spent a century listening. With our radio telescopes pressed to the void, we have strained to hear a faint whisper, a single, unnatural signal that would finally answer the most profound question we have ever asked. Are we alone? This is the work of SETI, the search for extraterrestrial intelligence. But there is another, more audacious and far more controversial side to this quest. A side that doesn't listen, but shouts. This is active SETI. And it forces us to ask a terrifying question. In a universe whose intentions we cannot know, is it wise to announce our presence? Our first deliberate shout into the cosmic darkness was a masterpiece of hope and data. On November 16, 1974, from the giant ear of the Arecibo Observatory, we beamed a simple 3-minute message towards the star cluster M13, some 25,000 light-years away. The Arecibo message was a cosmic postcard, a digital pictogram of 1,679 bits. It contained the numbers 1 to 10, the chemical elements of life, the double helix of our DNA, a crude sketch of a human being, and a map of our solar system. It was a message in a bottle, cast into an ocean of unimaginable scale. It won't arrive for another 25 millennia, but its transmission marked a turning point. We were no longer just listening. Since then, our calls have become more frequent, and sometimes more frivolous. We've beamed out a Beatles song, a Doritos advertisement, and countless other messages of peace and culture. Each one a flare sent up from our lonely bonfire in the dark. But our most ambitious message was not a radio wave. It was a physical artifact, a time capsule bolted to the side of our farthest explorers. In 1977, we launched Voyager 1 and 2. Their primary mission was to tour the outer planets, but their ultimate destiny was to drift forever among the stars. Attached to each was the Golden Record, a gold-plated copper disc containing the sounds and images of Earth. Greetings in 55 languages, the music of Bach and Chuck Berry, the cries of a baby, and 116 images of our world and our civilization. But the record also contained something else, something far more dangerous. On its cover, etched in gold, is a map. It shows the position of our Sun relative to 14 known pulsars, rapidly spinning neutron stars whose unique frequencies act as cosmic lighthouses. It is a simple, elegant piece of science, an unambiguous guide for any intelligent species to triangulate our exact point of origin. We didn't just say hello, we gave them our return address. So we have shouted, and we have sent a map. And in return, we have heard nothing but the cold, indifferent silence of the cosmos. This is the great paradox that has haunted us for decades. If the universe is teeming with life, where is everybody? There is one theory, a chilling and logical explanation for the silence, known as the dark forest. The theory proposes that the universe is like a dark forest at night, filled with silent, paranoid hunters. In this forest, survival is everything. Every civilization is a hunter, and every other civilization is a potential threat. Because you can never know the intentions of another hunter, whether they are peaceful or predatory. The only logical, safe move is to eliminate any other life form you find before it can eliminate you. To reveal your location is a death sentence. The single greatest survival strategy, then, is to stay silent. The terrifying implication is that the universe might be filled with life, but it is a life that knows to keep its head down. In this cosmic forest, humanity has been lighting bonfires and screaming at the top of its lungs. And then, in the summer of 2024, we heard a twig snap in the darkness. An object named 3I/, ATLAS, was spotted moving through our solar system at incredible speed. It was only the third interstellar visitor ever detected, and it was a giant, up to 12 miles wide. Almost immediately, the speculation began. A rock of that size, arriving from a distant unknown star, could it be a probe? An alien ship sent to investigate the source of those noisy radio signals? The idea that we were being watched took hold of the public imagination. But the science tells a different story. The object began to shed gas and dust, forming a classic cometary tail. Its path was a perfect, predictable gravitational slingshot, with no signs of intelligent course correction. It was not a pilot, it was a passenger, a celestial cannonball fired from another star system eons ago. 3I/ATLAS was not a ship, this time. But its arrival was a profound reminder of two truths. First, that the void between the stars is navigable. Objects can and do cross the interstellar gulf. And second, it showed how we as a species would react to a potential first contact, with a mix of wonder, excitement, and a deep primal fear. The dark forest theory suggests that if 3I/ATLAS had been a probe, its report back to its creators would trigger not a friendly visit, but a preemptive strike. An advanced civilization, seeing a noisy Type 0 species on the verge of mastering its planet, might decide that the safest course of action is to extinguish the fire before it can spread. The Arecibo message will not arrive for 25,000 years. The Voyager probes will not drift near another star for 40,000 more. The consequences of our actions are not for us to face, but for a distant future of humanity. We sent our messages and our map out of hope, curiosity, and a deep-seated need to not be alone. We can only hope that whoever, or whatever, eventually finds them, shares that same optimism,